T-minus 20 seconds and counting.
Deluge activity.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have liftoff.
Stage 1 propulsion is nominal.
Beginning pitch over.
And we're flying. Our 34th Electron vehicle is in the air and on the way to orbit after lifting off from Launch Complex 2. You can see the exhaust from those 9 Rutherford engines glowing bright as they propel the vehicle with Capella's satellites to space. Now that Electron has left the pad, its next milestone is max Q, the moment when the density of the air around the vehicle and its acceleration through that air creates the maximum aerodynamic pressure that the vehicle will experience in flight. You'll hear Mission Control announce this milestone soon enough.
Approaching max Q.
He will count you in, remember. Yep.
Saying max Q.
As you may have heard from our mission operator's call there, Electron has now passed through max Q. The vehicle has throttled back up to a velocity of over 1,000 meters per second, just a fraction of its maximum velocity as it proceeds to orbit. We're about to reach another 3 milestones in the flight, and each will happen quite quickly, so we'll explain all 3 in one go. To start, we need to separate the first stage of the vehicle from the second and third stage, also known as the kick stage, which holds Capella's satellites. The first stage is essentially a large fuel tank. Once that fuel is depleted, we jettison the tank so that the second stage can carry on to our orbital destination. To separate cleanly, we need to throttle down those 9 Rutherford engines on the first stage. This is known as main engine cutoff, or MECO for short. Once these engines have throttled down, the first and the second stage separate. Next, you'll see the vacuum-optimized Rutherford engine ignites to carry the second and the third stage the rest of the way into space.
MECO confirm.
Stage separation successful.
Stage 2 ignition.
MECO, Stage 1 separation and Stage 2 ignition confirmed and completed. Our 34th Electron mission is progressing nicely, and we're ready for the next set of checkpoints in flight on the way to delivering Capella satellites to their place in space. We are listening for the call to confirm that Electron's fairing, the pointing protective shell at the top of the rocket, has been jettisoned to expose the satellites in preparation for deployment.
Fairing jettison succeeded.
You can see it there on your screen. That's confirmation that the payload fairing has been successfully jettisoned and Capella's satellites are now exposed to space. Electron's second stage is continuing to orbit, travelling at speeds of over 8,000 kilometres per hour and currently at an altitude of over 100 kilometres.
That's another milestone checked off. The fairing is a millimeter-thin shell that serves a vital role, protecting the payload's inside from the awesome aerodynamic forces it sees as it breaks away from the atmosphere. Now that we're in free space, we can shed that extra weight to help maximize Electron's acceleration into orbit. Sitting on top of Electron, each payload might feel up to 8 times its own weight due to those smooth accelerations. As part of the structural analysis team, our job is to prove every component on the vehicle is tough enough to withstand the stresses of all those forces, pressures, and vibrations on ascent, while still being a lightweight and elegant solution.
HVB discharge nominal.
T plus 5 minutes, and it's time for the next set of checkpoints in flight as we progress towards mission success. Next up is a milestone unique to Electron, the battery hot swap. You might already know that our 3D printed Rutherford engines are also distinct for another reason. They are powered by electric pumps. These pumps are powered by batteries, which eventually run out of juice. This is where the battery hot swap comes in. We need to swap the used batteries out with another fresh battery and jettison the expended ones to free up some weight, all while keeping that stage 2 engine running smoothly, which is why we call it battery hot swap. Sometimes you can catch a glimpse of these battery packs falling away, so keep an eye on the right side of your screen. While you do that, we'll listen in from the call out from Mission Control.
Seconds remaining.
Discharge nominal, approaching hot swap in roughly 30 seconds.
Throttling down.
Hot swap successful.
Stage 2 propulsion holds nominal.
Battery jettison confirmed.
Electron's second stage is now running on a fresh battery. You saw it there, with the battery hot swap confirmed successful by Mission Control. We're in the stage 2 burn for a few minutes longer, but the next major milestone we have is SECO, or second engine cutoff. Similar to MECO, which happens before first stage separation, SECO is when the Rutherford engine on the second stage will shut down just before the second stage separates from the kick stage, which of course will continue on to payload deployment.
Now at 7 minutes and 10 seconds into Stronger Together mission for Capella Space, the second launch from our US launch site on Wallops Island, Virginia, with 4 minutes until SECO and kick-stage separation. Electron continues to make its way to orbit, currently at an altitude of 6,000 meters per second and a velocity of kilometers of around 200 kilometers over 6,000 kilometers per second velocity.
Stage 2 propulsion still nominal.
If you're just joining us, we're T plus almost 8 minutes into our 34th Electron mission, which is going through all of the milestones. Well, it lifted off the pad on time at 18:38 local time and passed through max Q, MECO, first stage separation, and second stage ignition without any event. Of course, recently we've just had the battery hot swap, and we're just waiting on SECO, second engine cutoff, before the kick stage separates from the second stage.
As Felicity mentioned earlier, coming up next, the engine on Electron's second stage will throttle down and shut off before the final stage separation. From there, we'll go into a coast phase in an elliptical orbit for about 40 minutes or so until the kick stage ignites its Curie engine and propel the Capella Space SAR imaging satellites on board to their exact targeted orbit before they are deployed. Payload deployment will mark the end of the mission, which will occur at around T plus 60 minutes or so. So let's listen in for SECO and kick stage separation.
SECO confirmed.
Nominal transfer orbit achieved. Stage 3 separation confirmed.
The space-optimized Rutherford engine on Electron's second stage has now throttled down, and the second stage has cleanly separated from the kick stage. The SECO and second stage separation milestones for this mission are complete. The next phase of the mission takes a little longer than that action-packed first 8 minutes after launch, but it's worth the wait. Electron's kick stage, with payloads attached, will now enter the coast phase that Lakita mentioned, as it propels the payload in an elliptical orbit towards the apogee requested by our customer, Capella.